All right. So far, when dealing with perspective, we've been dealing with something called constructed perspective. Perspective when drawing from imagination or memory. Now we're going to move on from constructive perspective to observational perspective. Perspective as it actually works in real life. Now, obviously, we haven't covered everything we needed to know in constructed two-point perspective, but this class focuses on observational drawing. And for observational drawing, this is equally important, if not more important, than all the other stuff that we've covered in this class. There's an additional complexity when dealing with perspective as it exists in observation, in that not every single object is going to be either in one-point perspective exactly or two-point perspective exactly. Things are rotated at all kinds of different angles, and also sometimes tilted or sometimes warped, not exactly straight. Here is the main complication. Let's imagine that we're looking at a cube that is in perfect two-point perspective. So in perfect two-point perspective, we're looking at objects exactly from a corner. I'm going to draw really, really small here, like this. And then we have angles that look like this. They recede back in space one way. And then, in perfect two-point perspective, the opposite vanishing point is going to be equidistant from the other one. I should probably establish a horizon line here. Let's run it all the way across my paper. Like this. Okay, so where would the second vanishing point be? It would be equal distances from the other one. Just estimating the depth here. Hopefully that looks somewhat accurate. Okay, so this is a cube in perfect two-point perspective. Let's imagine a bird's eye view of this particular scene. Let's draw another horizon line that looks like this. And imagine that we're looking at this cube directly from above. That would look something like a little bit smaller. Okay, I'm not making it exactly square. It should be square. But not the point. Okay, so this is the view of the cube directly from the top. Imagine that I'm looking at my cube. So I'm here. Here's my hair. This, and I'm looking at the cube straight on. Where would the vanishing points be? Well, they're going to point in the same direction as the walls of my cube. So here is one vanishing point, here's the other vanishing point. All that's really clear, really neat, really concise, easy to understand. But again, this is not the way nature quite often works, because quite often we're looking at a cube and we're thinking, wait a second, I can see much more of one side than I can the other side. So that might be a cube that looks something like this, where you have a vanishing point. Let's do it this way here. So here's one side, like this. Here's the front edge. I'm going to try to make these cubes more or less the same height. So I'm seeing a lot less of this side and more of this side, like this. All right, when you see more of one side than you do the other side, the vanishing point on the larger side is going to be further away. So you notice that this cube has a vanishing point that's more or less the same. Okay, I didn't quite do it. More or less the same as this one, yet it's further over, so the vanishing point is further away. When the vanishing point on one side becomes further away, the other vanishing point becomes closer, moves in. So in this particular cube, let's draw the back here. In this particular cube, the vanishing point is much closer than it is in this one, on this side. On the other side, it's much further away. So bird's eye view, this cube might look like this. Okay, so imagine I'm standing right here again. Up, up. I'm looking at the cube this way. One vanishing point goes this way, like this. The other vanishing point moves further away, this way. I don't know why this pen is not drawing. It should. Okay. Moves further away, this way, this way, this way. If the cube keeps rotating, if I start seeing a lot of one side, so this might be a situation that maybe looks like this. The vanishing point on the narrower side moves really, really close. It approaches the object. The second vanishing point is way, 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 way off the paper. It could be in some other room in my house. Let's put it that way. Right? Down the block somewhere. So you just take a slight shift of one vanishing point closer to move the second vanishing point further and further and further away. So here's the tricky thing with the perspective from observation. Quite often your vanishing point are not going to be on the paper, and one vanishing point is going to be so off the paper that there's no way to calculate it. It becomes very, very difficult. So that's a situation that maybe looks like this. Bird's eye view again. So I'm once again here, like this. You can see one vanishing point is really close, right here, like this. And the second vanishing point just barely tapers to the horizon, and once again, will meet the horizon line somewhere way off into the distance, until the cube is perfectly straight. So we're looking at the cube, I see no angles at all. The line in front and the line on top is perfectly horizontal. In which case, the vanishing points move so close in that one of them is directly behind my cube. So we're going to have a situation that looks now like this. Hopefully this looks familiar. This is one-point perspective. What happens to the second vanishing point? Well, it starts moving so far away that it becomes parallel to the horizon line and will never touch. So that is our famous one-point perspective cube, where all the angles on the top and the bottom are perfectly horizontal. Here I am again, and our vanishing points disappear to the horizon line this way, like this. So we're going to draw some cubes from quote-unquote observation. We're going to be working from an image. I'm going to show you guys how to deal with a situation where the cubes are not only not aligned with each other, but have vanishing points that are completely off the paper quite often.